Selamat sejahtera and a very good evening. My name is Sethu Analaki Muthiah, B1324106669, and for today I would like to present on our topic Lab 2 from our group 5, which is the belt friction analysis using capstan equation. So through this experiment we have three objectives. The first is to study the tension difference between F1 and F2. Second is to determine the effect of wrap angle on the tension ratio. And third, to investigate the effect of different belt materials on friction performance, namely leather material, rubber material, and hemp material. So throughout this experiment, we will have three key findings. The first being higher wrap angle equals to higher tension ratio. The second is the leather belt shows the highest friction. And for the third is the validation of the capstan equation. So next we will look into the methodology of this experiment.
Okay, Assalamualaikum and good night. My name is Muhammad Shazwi FITHRI bin MUSA and metric number B1324-10224. So I will explain about methodology. They have two experiments. First experiment is we do set up the pulley and place the rope onto the flat groove of the pulley. Then we adjust the initial F1 to 50 Newton. After that we set the rope angle, then turn the pulley counterclockwise. After we turn the pulley, we record the F1 and F2 readings. Then repeat for all angles. Next is experiment 2. Experiment 2, we set the angle to 80 degrees. Then we adjust initial tension, which is F1 to 50 Newton. Then we record the readings for F1 and F2. After we get the F1 and F2 readings, we calculate the coefficient of friction. After that, we compare with the literature review. Lastly, we repeat with other belts such as hemp, rubber and leather.
Assalamualaikum everyone. For experiment 1, we investigated the effect of wrap angle on the tension ratio F1 divided F2. So based on the result, the tension ratio increased from 1.302 at 30 degree to 4.44 at 180 degree. So this shows that increasing the angle of contact increased the friction between the belt and pulley, so resulting in a higher tension ratio. So the graph clearly shows this upward trend, which agree with the capstan equation. For experiment 2, we study the effect of belt material on the friction performance. Among the three materials tested, leather recorded the highest coefficient of friction at 0.862, followed by rubber at 0.413 and hemp at 0.317. So this indicate that leather provide the best grip and resistance to slipping. In conclusion, the results show that both wrap angle and belt materials significantly affect belt friction. So a larger wrap angle increase the tension ratio, while the leather belt provide the highest friction performance. Therefore, the experimental finding successfully validate the capstan equation. Thank you.
Based on our result, the tension ratio increased as the wrap angle increased. This can be explained using the capstan equation, where the tension ratio is proportional to E, coefficient of friction. As the wrap angle become larger and the contact area between the belt and pulley increase, generating greater friction and allowing higher force transmission without slipping. We also found the leather produce the highest coefficient of friction, while hemp produce the lowest according to the capstan equation. A higher coefficient of friction result in a larger tension ratio. Therefore, leather provide better grip and power transmission performance. Overall, the experiment successfully verified that both of wrap angle and belt material significantly affect belt friction behavior and support the theoretical prediction of the capstan equation.
Okay, for the conclusion,
the belt friction experiment successfully demonstrate the application of the capstan equation. The tension ratio increased significantly with increasing rep angle, confirming that larger contact angles generate greater frictional force. Material selection also affected friction performance, with leather producing the highest coefficient of friction and ham the lowest. These findings confirm that both rep angle and belt material are important factors in power transmission systems.